There are certain abiotic factors which mainly influence the organisms that are thriving in the intertidal zone. We are not going to look into all, but certain points which is very specific. First is the salinity. It's the salt content of the water column, right? So whenever the water is moved towards the low tide mark, there will be always the influence of evaporation or the precipitation, right? So whatever the water that are in the high tidal mark will get precipitated, and then the remaining salt will get deposited in the sand or the rocky shores. So there are two types of organisms. One is a euryhaline, which can tolerate a wide range of salinity in the rocky shores or sandy shores. That is, example, mussels and barnacles. And there is a cyanohaline, which can only tolerate a narrow range of salinity. That is sea stars, because these are mobile organisms and it can easily move from low tide to high tide mark. And the next are how it adapts. It closes up the shells, right, and it can stay inside. And then there are ionic forms, or how we have a sodium potassium channels, right? So whenever we take salt more, we used to drink water, right? So similar to that, there are ionic forms in the crabs and sea stars, which can help to withstand the salinity variation. Next one is UV light. Since when we expose to sunlight, we used to get sunburns, right, or the tanning of skins. Similarly, marine organisms can also get sunburns, especially when it is out of the water. So what we do is sunscreen, right? And similar to that, there are natural compounds that absorb the UV inside these intertidal organisms. And the another part is the protective shell. As I said, it can simply close the shell and then stay inside and then wait for the next turn. The next one is temperature. In the intertidal area, the atmospheric water temperature varies from 7 to 12 degrees, right? And then the air temperature varies drastically from 0 to 30 degrees centigrade. So whenever the organisms are out of the water, it has to withstand this greater variation in the temperature. So how the adaptations will happen? There is called evaporative cooling. So whenever the mussels or the barnacles or oysters close, it used to store a certain amount of water inside these shells, which is called, they have the mantle cavity which can store a certain amount of water. And another mechanism is the urethermal enzymes. Urethermal enzymes, nothing but the heat shock proteins and then antioxidants such as superoxide dismutase, catalase, and then other certain vitamins that can help to protect these organisms from the extreme temperatures. And the next one is desiccation, where the loss of water to the air. So there are certain strategies that have been adapted by these intertidal organisms. One is run and hide. Mostly these mobile organisms, like a crab, you can see that can hide inside the moist crack, right, or under the crevices. And then there are shelled organisms with only less water loss, like mussels and limpets. But there is algae which has to lose almost 60% of its water, and then it has to wait for the next tide to come in. And there are chitons in the rocky shores where it has to lose almost 75% of its water column and then wait for the next tide to regain. So if you look at the clam, it has a protective cover, right? It closes the shell and then stays inside. But other organisms like seaweeds and chitons have to allow the water to dry out and then wait for the next tide. A Litorina, a gastropod species in the rocky intertidal. So what it does, it retards the body inside and then it will make a protective coating on the operculum region. And then it sticks to the protective kind of a mucus and then it sticks to the rocky intertidal shore. And then it waits for the next tide to come in. And the next abiotic factor is the wave action. It has a high energy and it has the two biological consequences. One is the structural and the functional. When it comes to the structural, it affects the physical integrity of the organs. It usually disturbs and then if it comes to the functional integrity, the behavior as well as the foraging and the reproduction pattern will always get affected with the wave actions. And another typical factor which has been easily overlooked in these intertidal areas are the space, right? So because these rocky intertidal are a 2D world, and most of the organisms are epifaunal, which means which dwell on the surface of the rocks. So if you look at this photo, which is the scale is less than 15 centimeter, and here you can see different types of organisms, right? There is oyster and algae. You can see some chitin and then mussel beds. But if you look closely, there are almost different 8 to 10 types of organisms living in this small space. So move on to the biotic factors that are affecting the organisms. So one is the competition, another one is predation, herbivory, substrate settlement, and the osmoregulation. So moving on to the competition, it has to use the defense force, that reduces the competition of the individuals, or it has to coexist with the other species. So first one is the interference, which has a direct interaction with the organisms, and another one is the exploitative, where you can use a different resource for feed. Some may rely on certain species of feed for their survival, and some may depend on different food source. So another is the interspecific competition, which could be between the species, right, A or B, and then there is intraspecific competition, which could be between the individuals of the same species. Next is the predation, where the animals feed on other animals. So these predators could be generalists, right, which can feed on a wide range of prey items, like starfish, which can feed on mussels, limpets, barnacles, and all other organisms. And then there could be a specialist which can feed only on a single predator. So how to avoid the predators? You can always grow big so that some mussels are too big to be eaten by the starfish. And another is a space where the mobile organisms like crabs, limpets, which can easily move away and then hide inside the crevices so that it can avoid the predation by the shorebirds. And the third one is herbivory, where the animals mostly feed on the plants. So this is again similar to predation interactions. So how you will avoid the predation from the animals? You make a chemical defenses. Right? Certain organisms will produce sulfuric acid, like here desmaresia, and then it produces a compound like a bromine from by prionitis. So these chemical defenses will help to avoid the animal predators to feed on the plants. And the next one is physical defenses, where you make a thick shell using calcium carbonate. So that typical example is a coralline algae, so that predators cannot feed on these thick shells. And then last one is you grow above the intertidal height in the intertidal region, so that small predators cannot reach those areas to feed on you. And the last one is substrate recruitment, right? So whatever the organisms that are surviving in these intertidal regions or like adults, it has to undergo a larval phase, or you call it as a pelagic larval phase. So this larvae has to survive in the water column for certain amount of time, and then once it gets matured or metamorphosed, it will move on to the intertidal areas for the settlement. And this settlement rely on several factors, right? Several biotic and abiotic factors such as light, salinity, right? Chemicals are nothing but the chemical cues. Right here you have chemical cues, and then there is a current influence because it has to swim towards the land, right, for settlement. And there is a substrate, whether it could be a fine sand, whether it could be a coarse sand, or it's a rocky areas. And there will be a presence of adult organisms, whether it could be barnacle larvae or mussel larvae or oyster larvae. So it has to see whether the parents or the siblings are available in that particular substrate. And there will be hydrostatic pressure if the larvae is driven towards the deeper part, or if it is moving towards the shallow part. Then there is always a pressure influence. So all these factors are mainly important when we look into the pelagic larval phase for recruitment. To previously I explained about the keystone species, right? So what is a keystone species? It has been described by Payne in 1969. So what he does is he coined this term to describe the importance of starfish in this intertidal ecosystem. Why? Because this starfish, it helps to maintain the structure and integrity of this intertidal ecosystem. So if you look at the image, you can see the black arrows, right? So all these primary or secondary consumers have been taken by the tertiary consumers called thighs. So these are the gastropod, and then all these primary, secondary, and tertiary consumers are, the population of all these secondary and tertiary consumers are maintained by this disaster starfish or the predator. So because it's influencing the population, as I said, the space is more important, right? So this disaster starfish is maintaining the population of barnacles, limpets, bivalves, so that everyone can accommodate and then survive in this intertidal area. So these keystone species have disproportionately larger effect on the environment than expected.